Today's lesson is about trapezoids and kites. Now, these are your last quadrilaterals that you have to know about. So, to start off here, let's talk about a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. In a trapezoid, you have legs. If you look at the picture to your left, these are the sides between the parallel bases. So if we look over at the picture to the left, SR and TU, those are your legs over here. You will always have two bases, and these are the sides that are parallel. In the picture over to the left, it's ST and RU. Now remember, a trapezoid does not have to look like this picture right here. I know you see these parallel markings. A trapezoid could look like this. Try to draw my best. And there could be right angles right here. All they need is one set of parallel sides. Now, when you have these two bases in the picture down below that we were talking about before, you also have base angles. And there are two sets of base angles. You have angle R and base angle U. And you have base angle S and base angle T, because there's two bases. So that's just a basic trapezoid. But you also need to know the difference between trapezoid and isosceles trapezoid. So this is your next figure. An isosceles trapezoid is a trapezoid. Does not like me writing P's. There we go. That has congruent legs. So it has the properties of a trapezoid, one pair of parallel sides, and it has to have congruent legs. So we have this picture over here. I'm going to put markings here saying that it has one set of parallel sides. Oh, I've lost the ability to move my picture. Hold on, I'm going to put this on pause for a second. Okay, let me move this down. So here are your legs, and we're going to put markings saying that they're congruent. So when you know it's isosceles, you now know that both pairs of base angles are congruent. So A is congruent to B up there, and these two down here are congruent. Also, diagonals are congruent. So there's three things there you want to pull out about trapezoids. It has exactly one pair of parallel sides. If it's isosceles, both pairs of base angles are congruent and the diagonals are congruent. When you have a trapezoid, you can have a median or a mid-segment, and this is a segment that joins the midpoints of the legs. Segment that joins the midpoints of the legs of the trapezoid. There is a theorem that goes along with a midsegment, and that's our next thing. It says the median or midsegment of a trapezoid is parallel to the bases. So in this picture over here, if this is a trapezoid, we know that this is parallel to this. To know that this is a midsegment, you would have to know these are your midpoints. So this would be congruent to this, and this would be congruent to this, and you would know this is parallel. It says the midsegment, its measure is 1/2 the sum of the measures of the bases. So there's two approaches to this. One is saying MN, which is your midsegment, is 1/2 of base HJ plus base LK. Or if you want to take a different perspective, you can say 2 midsegments is the sum of the 2 bases. Your perspective, whatever you want to look at it as, either way, gets you the right answer. And that's everything you need to know about trapezoids. So there's a few questions down here. Number 1, when you look at this, you see these are parallel. We see that this is an isosceles trapezoid. If this angle is 142 here, we just learned that the base angles are congruent, so that's 142. To find the measure of angle R, you have to remember that you guys have parallel lines. And parallel lines, angle K and angle R would be consecutive interior, which means that they're supplementary, which means they equal 180 degrees. So to find angle R, we would take 180 minus 142, and we would get the measure of angle R is 38. Number 2 is a trapezoid. It says T and S are midpoints. So you can mark up your picture, and as soon as you know that's a midpoint, mid-segment, because it goes to the midpoints, you know it's parallel. The first question says if HJ is 14 and LK is 42, find TS. Well, that's the theorem right above that says TS has to be 1/2 of 14 plus 42. And you just do that math problem and you get TS equals 28. Using the same picture, different question, it says if LK is 19 and TS is 15, find HJ. Different approaches you can take. I'm going to put 15, which is TS, equal to 1/2 of 19 plus X, because we don't know what it is. I'm not going to distribute this 1/2. I am going to eliminate it. And to eliminate it, I'm going to multiply by 2 on both sides. That will eliminate this 1/2. So this is 30 equals 19 plus X. Subtract my 19, 11 equals X. So HJ is 11. And that's the notes on a trapezoid. We're going to go to the back and now talk about a kite. So this is your last one. A kite has 2 pairs of adjacent congruent sides, but not all 4. So if you look in this picture over to the right, MN is congruent to NP, and RP is congruent to RM, but not all four sides. The thing that you need to remember about a kite, the diagonals are perpendicular, always. So I can go over and put some markings there. It says one pair of opposite angles are congruent. Only one pair. This is the angle or angles between the non-congruent sides. The angles between the non-congruent sides. So if I go over to this picture, this angle here is congruent to this angle here because they're the angle between the non-congruent sides. And there's one last thing that you would figure out from knowing these things. It says one diagonal divides the kite into two congruent triangles. So I'll grab a highlighter here. The two congruent triangles would be RMN. So they have a congruent angle, a congruent sides, angle, 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 side, angle, and then this triangle down here. So those two are congruent. And that's your kite. So the last problems to try, here is this picture. The first one says we have a kite over here. Find J, R, K. If this is a kite, I know this, whoops, sorry. I know that HG congruent to HJ. I know these are congruent. I know this big angle is congruent to this big angle, and it said diagonals were perpendicular. So when it says find JRK, the measure of JRK is going to be 90 degrees. Next it says RJ is 3 and RK is 10. So I'm going to pull out what I see there. I see R, J, and K. RJ is 3, RK is 10. I need to find JK. Well, there was something else there, which was a right angle. And when I see a right triangle and I need to find sides, I need to think of Pythagorean's theorem. So this would be 3 squared plus 10 squared is c squared. 109 is c squared. And to undo squaring, you take the square root. There are no perfect squares in 109. So JK would equal the square root of 109. The next one says if GHJ is 90, so we're going to put a 90-degree angle there. And it says did I put that in the right spot? GHJ, yep. GKJ, so this is 90 up here. And GKJ is 110 down here. It's asking to find HGK. And let me grab green. HGK is right in here. So you need to recall that when you have a kite, you have two congruent triangles, which means when you have that, the angles are bisected. So 110 down at the bottom, we're going to have 55 here and 55 here because they have to be the same. 45 here and 45 here. So if we want to find HGK, we would take 45 and add 55 and get 100. And that's a triangle, so 180 minus 100 would be the measure of HGK would be 80 degrees. Number 6 says if HJ is 7, so I'll grab pink. HG is 7, find HJ was 7, find HG. That also has to be 7. I'm going to go delete these pictures over here because this triangle is getting kind of messy. So I'm going to get rid of these. So you might want to pause if you didn't catch everything. So I'm going to erase this. All right. It says number 7 that HG is 7. Here's a 7. GR is 5. And there was a right angle here, remember? Find HR. We don't know that. So this is another right triangle. Here's the right angle. X, 5, 7. So that would be Pythagorean's theorem again. X squared plus 5 squared is 7 squared. X squared plus 25 is 49. Minus 25 on both sides. Pull this down. X squared is 24. Square root, there is a perfect square in 24, which is 4. So that turns into x is 2, square root is 6. So HR equals 2, the square root of 6. And there's one last question here. It says GHJ. GHJ, so let me go ahead and erase that since this is the last question. I'll grab orange. It says GHJ is 52. So this whole angle, well, I guess it's pink now, is 52. But remember, you know that bisects. So this angle over here is 26, and this is 26 if we need it. It says GKJ is 95. So this whole angle down here is 95, which means if we need to split this one up, that's 47.5, 47.5. It says find HGK. HGK would be here. So to find HGK, remember that these two are congruent. This is a four-sided figure. Four-sided figures from the first lesson of this chapter. You take 180 times 4 minus 2 to get 360 degrees in a figure. If you currently have 52 degrees and 95 degrees, that total is 147. If I take 360 degrees in the kite minus 147, I get 213. So I'm going to take 213 degrees and divide it by 2 because they're equal, and I get 106.5. Now that's not the only way you could find that. So HGK is 106.5, but you could also have done the triangle on the left and the triangle on the right to figure them out. If you have any questions, email me, Zoom me. I'll be on today to help.